Hi guys, my name is Manas Adhikari. I am 9 years old. So today we're going to determine whether the function fx equals to x sine 1 over x if x is not equal to 0, and 0 if x equals 0 is continuous at a equals 0. So first of all, in order for f to be continuous at a is equal to 0, at a equals 0, comma, the following three conditions must hold, period. So now number 1 is f of 0 is defined, then period. And then number 2, limit x opposed to 0, f of x exists. And then number 3, limit x opposed to 0, f of x is equal to f of 0. Okay, let's close. So now, number 1 says f of 0 is defined. Yes, f of 0 is defined because f of 0 is 0. So that means f of 0 is equal to 0 is defined. So now we do number 2. Number 2 says limit x over 0 of fx exists. So now we have limit x opposed to 0. Limit x opposed to 0. And we know f of x is x sine 1 over x. So we have x sine 1 over x. So now for any real number theta, now I have -1 is less than or equal to sine theta is less than or equal to 1. So now let theta be equal to 1 over x, comma, where x cannot be equal to 0. So now I have -1 is less than or equal to sine 1 over x is less than or equal to 1. So now I'm going to erase this, and this. So now it says x is not equal to 0. So that means 1 can be that x can be positive. And if x is positive, we have to multiply on all sides of the inequality by x. So now if negative x is less than or equal to x sine 1 over x is less than or equal to x. Another one can be that x is negative. So that means you have to multiply all sides of the inequality by x, but then we have to change the sign of the inequality. So if negative x is greater than or equal to, we have x sine 1 over x is greater than or equal to x. So now I have limit x opposed to 0 x, and that is equal to 0. So and then we have limit x opposed to 0 of negative x, and that is equal to 0. So then by squeeze theorem, limit x opposed to 0, we have x sine 1 over x, and that is equal to 0, which that is equal to f of 0, which now f of x is continuous at x is equal to 0. Thank you guys for watching my video today.